Permit Required Confined Space hazard identification is a real weak spot with just about every organization that I've worked with. In fact, I've only seen it really done well in one place. There's a natural gas power station down in Klamath Falls, Oregon that has this process absolutely nailed. Otherwise, when I ask for the Permit Required Confined Space hazard evaluation documentation, I would usually get a blank stare. Now, this is a really critical point. Permit Required Confined Space hazard evaluations are not something that is done as part of the entry evolution. It must be performed in advance by a sufficiently qualified person. In construction, the regulations say that the evaluation must be done by a competent person. For evaluation of potentially hazardous atmospheres, OSHA says, evaluation and interpretation of these data and development of the entry procedure should be done by or reviewed by a technically qualified professional, such as an OSHA consultation service, a certified industrial hygienist, a registered safety engineer, a certified safety professional, or a certified marine chemist. When evaluating an atmospheric hazard, you must get a professional involved with interpreting the results and developing a mitigation plan. If you don't have a specialist on staff, you're going to need to find one. You can hire a specialist. I also recommend checking in with your workman's comp carrier because sometimes they have an industrial hygienist on staff that can help you with this. Also, you can check with your local OSHA office and see if they have a consultation service available. Here in Oregon, if they are available, the OSHA office will sometimes send out an industrial hygienist to do an evaluation for free. Evaluating a confined space for hazard is a skill that you hone over years of experience. I usually like to break it down into 3 steps: a review of what can go into the space, a review of what is in the space, and a review of what can go out of the space. A great place to start is with looking at a basic schematic of the space. That way you can identify what goes into the space, what passes through the space, and what comes out of the space. The workers will be performing an entry to check the propane tank and the associated piping for leaks. Let's look at the image first. Here we have a space containing a propane tank. It is accessed with a vertical ladder. Here's a basic schematic for the space. Now at first glance, I know what everybody's focusing on, the propane tank, and that's a good thing to look at. However, the thing that makes me most anxious when I look at a space like this is the floor drain. This means, by design, this space is expected to have some sort of leakage into it. It also presents a much larger concern, but we will get to that in a little bit. So let's analyze what goes into the space. We have an access hatch at the top. This would allow the entry of air or potentially contaminated air, and obviously potentially flooding. Flooding may come from a rainstorm or maybe potential drainage from another area. You can see from the diagram that there is supply and exhaust ventilation. Now this brings up an important question. Supply from where? Does the supply provide clean, fresh air? Does the supply come from another space? Are there any potential atmospheric hazards near that supply, like oil wells or car exhaust? We have both electrical cabling and water that flows through the space. These are contained and do not terminate in the space. So unless there are signs of leakage or damage, isolating those lines probably wouldn't be required. Now let's take a look inside the space. The most obvious hazard we have is the propane storage tank. NFP 58, the liquid gas storage design criteria, does not allow for leakage in a propane tank. It can happen, but it's pretty rare. However, the mechanical connections to the propane tank are often set up in-house, and it is the mechanical valves, fittings, seals, and gaskets where the leaks tend to occur. Also, if the tank is overfilled and the space heats up a little bit, the gas can expand and lift the relief valve. So we know from just looking at the picture that a flammable gas hazard is possible. Is the fixed access ladder a hazard? It is a restricted means of entry or exit, so it does meet the criteria of a confined space configuration. If it interferes with the worker's ability to quickly exit or be rescued, then it is a permit hazard. ANSI Z17-1 does say that fixed ladders can be used, but it also says if they are narrow, steep, or lack required fall protection, alternative entry methods such as winches or bosun's chairs should be considered. Now let's take a look at what goes out of the space. The gas from the propane tank flows into a distribution system, so anything that flows into the system can flow back. The exhaust ventilation blows out of the space, but we need to know where it blows to and see if there's any possibility of blowback. And then we have that mystery box right in the middle of the floor, the dreaded drain. Does the drain connect to a drain header, which then could connect to other hazardous spaces? Even worse, does it connect to a sewer line? If it does, there is a potential entry route for all sorts of hazardous gases. This includes hydrogen sulfide, carbon dioxide, carbon monoxide, and methane. Now, if there are any industrial waste or fertilizer in that drain, you could also be facing ammonia, volatile organic compounds like benzene, and sulfur dioxide. Sewer gas exposure is one of the leading causes of fatalities in confined spaces. So can you see why having a professional review atmospheric hazard analysis is so important? In summary, the major hazards that I take from looking at this space are the fixed access ladder, flammable gas from the propane system, engulfment hazards from the access hatch and the floor drain, and potential atmospheric hazards from the floor drain.